All right, so we're going to do some examples using implicit differentiation. So remember, one of the things that you need to notice, because I'm also teaching you critical thinking skills, is when do you need to use implicit differentiation. So one of the ways that you're going to notice is that you do not have a function. You've got an exponent attached to your y. Okay? So this is not going to be a function. So as long as you have a y to the first, then you can process this whole thing out, rewrite it in function notation, and you're good to go. And then you don't have to use implicit, but now we do. So what do I have? I have a 6x squared minus an 8y squared, and that equals 4. So again, I have to use implicit because my y has has an exponent other than 1. So what I have is, how do I take the derivative of the first term? I take the derivative just like I've been doing the whole time, so drop your exponent out front and multiply. Drop your exponent by 1, and then times the change in x, or times dx. And then I'm going to have a negative 16 y to the first times dy. So remember, we're using the dx and dy notation instead of x prime and y prime, or f prime of x, or whatever, because we're trying to get this to a situation where I can solve for dy dx. So I have two terms equal to 0. He has a dx, so I'm going to shove him to the right. He has a dy, so he stays. So I'm going to subtract 12x dx from both sides. And now I want to get dx over to the other side. Well, it's joined by multiplication right now, so divide it over. So he's gone that way. And now I need to get dy dx by itself. Well, negative 16y is connected to that by multiplication, so divide it over to the right. So he's a negative 16y. So now I have dy dx equals, my negatives cancel. 12 over 16 is going to reduce to 3/4, and x stays on top and y stays on bottom. So what you have is the formula for slope of the tangent line for any point on the graph. And remember, this includes x's and y's because it's not a function. Or you have the formula for instantaneous rate of change or velocity. So that is an example. Let's get a couple more in here. We can do number 2. So number 2 says x to the third plus y to the fourth is 25. So again, I have this term, and this term. It's not a function because he's raised to the 4th power. So I'm going to use implicit differentiation. So the derivative of x to the third is 3x squared dx. The derivative of y to the fourth is 4y to the third dy, and that equals 0. And I'm going to subtract this over to the right side. So 4y to the third dy is a negative 3x squared dx. I need to divide both sides by dx. So I'll have dy dx. So he's in the numerator on the right. He'll be in the denominator on the left. And I need to divide both sides by 4y cubed. So he is 3x squared over 4y cubed. And that is the formula for slope for a tangent line of any point on the curve. That's the formula for instantaneous rate of change or velocity. All right, so let's ramp it up just a little bit. I've got a 6x squared times y plus a 6y squared times x, and he equals negative 4. So remember, we're going to take a derivative. I don't like the fact that he has a 6 and he has a 6 because it's kind of messy. So I can go ahead and divide everything by 6 right now. And so what I have is x squared y plus y squared x equals a negative 4 over 6, or a negative 2/3. And I can do that because my constant's fixing to go to 0 anyway. So all the 6 does is stretch and compress. So it would have divided out at the end anyway. So here's what I've got. So this is where you want to start grabbing colored pens. I've got x's and I've got y's in my first term. Okay, so if I ignore everything else, I have to take the derivative of x squared y. So I have variables times variables, which means this is going to be product rule. So I have the first, which is x squared, times the derivative of the second. So the derivative of y is 1 dy. So don't forget your dy. So first times derivative, first times derivative of the second, plus the second, times the derivative of the first. So the derivative of x squared is a 2x dx. And so remember, this is not d times y, this is not d times x, this is the derivative of y, or the change in y. This is the derivative of x, or the change in x. And remember, order doesn't matter in multiplication, and so I just kept it in the order that we brainwashed you into, where constants go first, and then our variables are in alphabetical order. So now I can do this thing again. So I have y squared, and I have x. So that's going to require that I use product rule. So I have the first times the derivative of the second. So the derivative of x is 1 dx, plus the second times the derivative of the first, which will be a 2y dy, and that's going to equal my 0. All right, so here's what I got. I got 20 million things going on. If it has a dy, I am going to leave it on the left. So he's going to stay on the left, and he's going to stay on the left. If it has a dx, it's going to move to the right by addition or subtraction. And remember, we're doing this so that I can end up dividing the dx off of the left, off of the right, and he'll be the denominator of dy in the left. So everything with purple stays. So I've got an x squared dy plus a 2xy dy equals, and I subtracted him over. So he's a negative 2xy dx and a negative y squared dx. And now you run into an issue because I've got dy's all over the place over here and dx's all over the place over here. You got two options. One option is to combine like terms because these both have dy's, so I can put those together. Well, they're not like terms, and so that's going to be harder. So your other option is they both have a dy, so factor it out. So if you can't combine like terms, factor out what's common. So I have an x squared plus a 2xy dy equals, and then same thing over here. They're not like terms, so I'm going to factor out a dx. So I have a negative 2xy minus y squared dx. And I'm running out of room on my paper, which means I am going to divide both sides by dx. And then I'm going to divide both sides by this. So he's the numerator here, he's the denominator here. So that gives me an x squared plus a 2xy, and he reduced on the left. So this is your answer. So that is the formula for slope for any point on the graph. For its tangent line, it's the formula for instantaneous rate of change, and it's the formula for velocity. So we're going to start organizing with colors. And let me do one more like this. Just a little bit more exciting. All right, so here we go. Ooh, maybe I'll do two more. All right, so my original problem says the square root of xy equals x to the 9th y plus 78. All right, so what I want to do here is figure out what's going on. I know that this is product rule. That's fine. What I don't know is how to handle this. And so you have two options. Recognize that the derivative of the inside is not 1, so you would have to use chain rule. Or recognize that that radical belongs to both variables. So what I'm saying is I can rewrite that. Remember, that would be an xy to the 1/2. So I'm going to rewrite him as an x to the 1/2 and a y to the 1/2 equals x to the 9th y plus 78. So now I can just do plain old product rule here. I don't have to worry about other weird stuff. So this one, I have first and I have second. So I have the first, which is x to the 1/2, times the derivative of the second. So if the red thing is the only thing you're looking at, that means you'll have a 1/2 y to the negative 1/2 dy. So first times derivative of the second plus the second times the derivative of the first. So the derivative of the purple stuff is 1/2 x to the negative 1/2 dx. So that's this part. Equals, I will have first and second. So I have the first is x to the 9th times the derivative of the second is going to be 1 dy plus the second times the derivative of the first is going to be a 9x to the 8th dx. And then we're done with him, and the derivative of 78, 0. So if he has a dy, I want him on the left. So that means I'm going to have to subtract him over. If he has a dx, I want him on the right. So I'm going to have to subtract him over. So what I have now, I've lost my pencil, is crooked. What I have now is x to the 1/2 times 1/2 y to the negative 1/2 dy, and I'm going to subtract this one over. So he's a minus x to the 9th dy equals 9x to the 8th y dx, and I'm going to subtract him over. So minus 1/2 x to the negative 1/2 y to the 1/2 dx. So bigger picture is I have this term minus this term equals this term minus this term. So there's only 4 terms up here. There's ugly. But these are not like terms, so I can factor out a dy. These are not like terms, so I can factor out a dx. So this becomes x to the 1/2 times 1/2 y to the negative 1/2 minus x to the 9th, and I factored out a dy, equals, on this one I'm going to factor out a dx. So 9x to the 8th y minus 1/2 x to the negative 1/2 y to the 1/2, and I factored out a dx. So at this point, I just have to divide the numerators that don't belong and make them denominators of the other side. So this dx needs to be the denominator on the left, so divide both sides by dx. And I'm running out of room, so I'm scooting him over. This is my numerator. Over, this is my denominator. So that is your formula for slope of a tangent line for any point on the curve, instantaneous rate of change in velocity. So here's the deal. You can clean this thing up. but I'm going to leave that to you.